Hello and welcome to Apropos, a conversation between Clojure programmers that you can join in live on YouTube. We're going to discuss a few Clojure news items and share our opinions on them. Then we'll jump into a REPL and code some exercises or do some demos. If you're joining us live, feel free to comment in the chat and we'll try to address the questions. Today we got a short panel. We got Mike.
But I do have a beard.
Yes. And we have Eric. That's me.
Yeah.
How are you doing?
Howdy.
Oh,
Others are either out sick or too busy. I was almost sick this week, but I got better.
well, we got two beards.
Yes.
That's a quorum.
Yeah.
So we can go on with the show, and they are happy that we're going on. So that's not a problem. Right. So there's a little bit of news, and then we have actually listener questions. Wow. Thank you, listeners, for the questions. So the first point of news is that it appears that there's going to be a 10.0.1 point release, and this is to fix a regression with, well, I'm not quite sure. There's some change to the JIT that caused a performance problem for.
Yeah, I don't fully understand it at the bottom. I mean, all I know is the manifestation is if you have something in your user CLJ, something related to maybe static initialization or something low level. But if you have enough stuff in your user CLJ, you'll just see slowdowns. Things will work.
And like severe slowdowns, right? Like going from 5 seconds to 30 seconds to start up, something like that.
Yeah. So for me, using like React Native, which has like the most popular tool there is Read Natal. That one, it normally would take like 10 seconds to get up and go normally. But then with that regression, you would wait like 40 seconds before it was running.
Wow.
So yeah. Because I noticed this because I got a brand new Mac and I was like setting everything up, right? And I got the newest JDK on there and I was like trying things and I'm like, this thing has taken a long time to start up. And then I went and looked at my old laptop that's like a 2004 laptop and it was running faster than this brand new iMac, you know? So I'm like, what is going on? So I finally realized it was the JDK doing it. And then
that you were running 11?
It was actually, I was still running Java 8. But it's like the newest, the 2.01 release of Java 8 even had that regression in it. Yeah, because it's like I guess a defect that spanned all the JDKs and they had to patch it, you know, with a hot release or whatever. Yeah.
Right.
But
well, it seems like they've got a fix, right?
Yeah, I've been running that latest Clojure. Yeah, it's really easy to do. You just I think so. If you're using deps or any tool, right, you can just specify that version in your line again or wherever you would specify deps, and then you're using that version. And I've been using it for a week and it's been fine. It runs fast and
cool.
I haven't timed it, but it feels fast, right? You know, you would notice as a human being, you notice 40 seconds versus 10.
Right. Oh yeah, that's a big change.
Yeah,
for sure. It is nice that that Clojure the version is in the dependencies and not like something you install on your machine, right? Like I've had that trouble with Ruby or Python where people are like, you have to run this version of Ruby, and it's like, well, that's a different version from what I have installed. Like how do I run that version? And there's all sorts of like systems for like running. I don't know exactly how they work, but they set up the environment so that you can have multiple Ruby versions installed, and as you enter a directory, the Ruby version is switched for you.
Okay.
So that project has a certain binary for it.
Yeah. Okay. Yeah, I don't even know how does Leiningen switch. I mean, is it with deps? It's just a bash script, right? That starts everything up, and then it probably reads.
I mean, Leiningen is just
also the same thing.
Too, right?
Yeah.
It probably does something at the beginning.
Yeah.
Before it starts a JVM.
But that is a good point. You can just update to the latest by just changing your config, and it can be on a per project basis, right?
Right.
Whichever one you're working in, and yeah.
So nice. Um, it's one of those little things that just makes it nice that you don't even think about until you have to go to another language.
Yeah.
I just want to mention
Mhm.
there are two other things in that point release, this beta that's out now.
Yeah, yeah,
There apparently, if you threw an exception
yeah.
in the runner, not the REPL, but in the runner, and it was
Mhm.
uncaught, it would have printed a stack trace because that's the normal Java behavior. That's how I understand it. That's what the JVM does
Okay, yeah,
when
yeah.
like an exception just goes off the
Mhm.
top of the stack. Um, and so what happens is like you just have this really crappy stack trace like we used to have in
Yeah,
Clojure.
yeah.
And so they've made it so that it has the new nicer stuff for those exceptions. And those
Yeah,
were just
yeah,
overlooked when they were doing error handling stuff
yeah. And
before.
I think it's true that that was also overlooked in ClojureScript, because
Oh.
ultimately, that new enhanced error handling was ported over to ClojureScript, and of
Mm,
course, it was a high fidelity port. So that
right.
lack of handling that part was not
Bug for
ported from.
bug.
Yeah, yeah. At
Assumption
least we
for
got it right. Yeah,
assumption, omission for omission. Yes, nice.
yeah.
And apparently, there's been some Java 12 testing problems.
Oh,
The
okay. Yeah.
test didn't run cleanly, probably some warnings or something, and they just had to um, rework the tests, and so those are now in the new beta. Java 12 was released recently, so
And the entire time I've been using Clojure, I've never seen this occur. I've never seen a .1 release.
right.
Yeah.
It's like
I
it's
don't remember when I started using Clojure. Was it like, when did you start it? It was like, for me, I
I
think it was
started
1.5 or 1.6. I don't
I
know.
started
Or
before that.
1.7.
I don't remember exactly. Was it
Uh,
I mean, it could have been just pre 1.0.
well, I know you were using it before I was, because when I started learning it, I was reading your blog posts about it. So
Uh-huh.
you had already been using it. You
Yeah.
had to have been, because of causality.
Right, right. I seem
Right?
to
Yeah.
remember, like, maybe 1.2 had a point release? I don't remember,
Yeah.
actually. It's this
Yeah.
I don't remember the last time this has happened where, um,
Yeah.
where there was some bug or something, but
Yeah.
notice this is all regressions, like, due to something else.
I know. Yeah. If you were going to argue that point, you could say, like, this is not a closure bug.
Exactly.
It's something else that. So
Like, Java 12 came out and changed something, and so they had
yeah.
to redo the test, and it's just in the test, it's not even in the
Yeah.
yeah, interesting.
So I guess that's a consequence of having good long betas, right? Like Clojure tends to beta test for
Oh,
a good half a year, right?
Zach Oak says there was a 1.5.1,
Okay.
and
Yeah.
Ed Buller does say there was a 1.2.1. So,
Mm,
that was yeah, that's what I remember.
okay. I think I started with 1.6, maybe around there.
Java
Yeah.
12 is
Yeah.
so someone is asking, this is
Okay.
from
Yeah.
Jason, is asking if Java 12 is the new Java 8. And I think what he means by that is this a long-term support release, and it's not. Java 11 is the long-term support release. So if you don't want to upgrade, you should stick with Java 11, for a couple years. Um, I think it's every four releases, which means every 2 years is a long-term release.
Okay. Okay.
But of course, Oracle has like complicated it all with their
Hmm.
licensing issue. So um, you can this is the way they explain it. I haven't checked this out because I just learned just now that Java 12 was out. But
Yeah. Yeah.
um, apparently you're not supposed to be able to download Java 11 anymore, the Open JDK build. So
What?
yeah, right. So they just they
Like it?
stopped releasing it. It's like not available anymore. And that's why there was such hoopla about like third-party builds,
Okay.
because someone has to provide this thing, right? Because people are betting their business on JDK 11,
Yeah. Yeah.
and so they want people who are starting today instead of setting up a new computer to be able to download this thing. Which is
But
why.
you're saying like they actually removed like the download links or something like that?
Yeah, I'm gonna check it out right
That's interesting. Yeah.
now. Look, this is live.
Yeah.
It's happening live, folks.
Okay. Yeah.
Okay, open JDK.
Yeah. Like you could usually download like if you want Java 8, you can still get that thing, right? And
But you can't get it from Java Oracle.
from Oracle. Okay.
Okay, so I'm
Yeah,
trying
yeah,
to see where the downloads are.
yeah.
Download install.
This is kind of like
Okay,
Apple where you
so
can't
they do
download.
have a JDK 11 still available.
Okay, that's good. Because you might need it. Like if you were
They were probably just threatening. But I'm looking for 12. I don't see 12 yet on this page that how to download.
Yeah.
Okay, so they do have a 12. If you go to the homepage of the openjdk.java.net, you can find a link to download JDK 12. It's like /12. But if you go to the download and install page, it does not have JDK 12 on it. Okay, so but 11 is still there. You can still get 11. So they didn't remove it. But I don't know. I just wouldn't rely on that. They have publicly said that they're not going to continue supporting it and leave it available, which is just very weird.
Yeah. Well, for me, Java 8 works fine with Clojure. I mean,
Java 8 was nice.
I mean, you really can't tell any difference, right? I guess you could if you really dug deep.
Right.
I never programmed anything at that low of a level though, for it to matter.
Right.
Like, I guess there's new public APIs that might be exposed in the later Javas. I don't know.
And Java 9 broke so much stuff.
Oh yeah.
That's just been my experience. I had to redo all these courses and retest the code for Java 9.
And that was like uncharacteristic. That kind of a release, because usually you could just upgrade to the latest Java and something might break, but this time it really did with Java 9. It was like a lot of stuff was breaking.
That's right.
With the class loader stuff, and yeah,
the modules and right. I'm sure the precompiled code still runs, right? All those class files,
right? The binary. Okay, yeah.
But you know, you just assume an API is going to be there, and it's not anymore. And what do you do? Okay. So I promised a listener question, and I this question came out a while ago. This was from Jeff Friesen. He was asking about ClojureScript and like whether ClojureScript would do well to move to Webpack instead of Google Clojure and NPM modules.
Okay, yeah.
And
I wonder what he meant by that.
Well,
in the sense that ClojureScript depends on Clojure, right?
On Google Clojure, right?
That's always there.
But I think what he was saying is that the JavaScript world has standardized on Webpack. It appears.
Okay.
Who knows how long that'll last? But that
okay. So what is Webpack then? What is that thing?
Claiming a lot of the same features and benefits that we have had in Google Clojure for a long time.
Like all the tree shaking and all that.
Yeah, exactly. Where do they?
Oh, okay.
Where do they line up? So, do you think you can handle that, Mike?
Oh, okay. So, given that I know nothing about Webpack, I can speculate that.
Yeah.
I mean, so I can say, like, I can definitely say, like, well, what if you wanted to take ClojureScript and hypothetically pull Google Clojure out from underneath it and then switch to Webpack? That'd be an interesting thought experiment. ClojureScript uses Google Clojure fundamentally for its namespace realization or implementation, but maybe you could pull that off in some other way, you know?
And like do a common module system or something.
Maybe, yeah. Because I mean, if you imagine like a lot of ClojureScript, a big swath of that stuff just compiles to JavaScript, right? It's not really tied to Google Clojure, but it would be painful to make those changes. Like it's like all throughout the compiler's code base, the fact that it uses Google Clojure and it's interwoven throughout it, and so that would be a big, huge task to like let's say Google stopped supporting Clojure one day and they shut that whole project down and ClojureScript was just using this dead thing, and you're faced with, okay, we got to move on to whatever's next. That would be a big effort to pull it out, but it's theoretically possible, right? A lot of there's a lot of we rely on Google Clojure for the runtime library, like like the string functions and all the like the low level stuff that comes from what's called Google Clojure library, which is different from the Google Clojure compiler.
Right.
But yeah, so I don't think there would be much interest right now in making a huge change like that. That would be
No,
I mean,
no,
it's difficult enough to like. I just recently I was just trying to keep up with the latest stuff that's going on in Google Clojure, just trying because every now and then they will break ClojureScript inadvertently because ClojureScript depends on a lot of the internals of Google Clojure compiler and whatnot. So it's like a maintenance burden to even keep it up to date with the latest stuff that's in there. So that's I'm just saying that's enough work, just keeping up with Google Clojure and keeping it working with that stuff properly. It would make me question, like, where would the effort come from? Where would the people come from to do that conversion?
Well,
it would just like be a huge conversion. But yeah, it's an interesting thought experiment. Like, yeah, what if?
Yeah, I mean, in terms of the okay, so let's see why we might want to do that.
Yeah.
So Webpack, I think one of the nice things about Webpack is it does have a lot of, like, let's just call it labor behind it. There's a lot of people who are working on it. It does run a lot of code through it, so it's kind of got production tests already. And they're very focused on keeping it compatible with just, I guess I would call it regular JavaScript.
Yeah.
It's
not like it doesn't have the same constraints that Google Clojure has,
right?
Where you have to write stuff in a weird style. Yeah,
exactly. That it leverages like constraints to give you better optimizations. And so I think with that, Google Clojure has better optimizations, like
because of that. Yeah.
Yes. Now there's questions about whether that's significant. There are even questions of whether we need optimizations at all.
Yeah, right.
Given that if you just gzip it, like that's pretty compression already.
Yeah. Yeah. Like, remember when like MP3s first came out and you were worried about the compression rates?
Yeah.
When's the last time you thought about that stuff? That's all gone away now. You just download your music and you don't care anymore. That's probably going to ultimately happen with all of everything, right? Given enough time and enough technology, enough bandwidth.
Right.
The need to compress things will go away over time.
Right. But there's still the idea of getting rid, like being able to include a large library.
Yes.
And
only
only use 2 functions from it, and somehow the rest of the library is just not included.
Yeah. Does Webpack not do that for you? Is it?
It's just not as good.
Or it's just not as good.
They call it tree shaking, but it's not, because it's hard to track down the dynamic stuff that people do in JavaScript, which is disallowed in the Google Clojure module system. It's just not possible to do the kind of tree shaking that we can do.
Yeah, I think if it could magically happen, like if ClojureScript could support these things,
Right. I mean, the other idea,
right?
the other idea would be that it could be a Webpack module, so it could be in the pipelines and tap into that like whole ecosystem, just like converting from ES Infinity to like regular JavaScript.
Right.
Which is done, in this Webpack pipeline. That would be cool if you could have ClojureScript as part of your pipeline.
Yeah.
Yeah, I think that I also look at it like when ClojureScript first came out and it was announced that it was using this virtually unknown thing called Google Clojure.
Yeah.
People were like, "Oh, but what about jQuery? It's like the standard. Everyone's using it."
Yeah, and all these arguments about that. Yeah.
And this was back in 2011 when it was true. Everyone was using jQuery and there was nothing else.
And you couldn't see that it was ephemeral at the time. Yeah.
Right. It just looked like, oh, you're going to leave all this stuff behind and all the ecosystem. And I feel like Rich Hickey just has a much longer view on these things. And I don't know. Like I also look at so Google's products, their web products are built in Google Clojure, meaning
Right.
they've got the Google Clojure compiler, they're using the Google Clojure library and the Google Clojure.
Yeah.
I think it's still called the library, but it's like all the widgets and stuff,
Okay.
that are
Like
included in there. The stuff that you rarely use,
the
but
UI templating thing or whatever. Yeah.
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 Well, and
Okay.
like, they've got drop downs and modal windows and things like that.
Yes. So
But
Rich
like,
saw this stuff and he somehow was able to predict that Google would still be at least using it 10
yes,
years out of it.
right.
Yeah.
And that they're still extending it. But Google's web products,
Mhm.
like say, you might not like them, but they are not buggy.
Right.
I
Yeah.
want to, emphasize that they have
Mhm.
found the problems with JavaScript, wrapped them up in libraries,
Yeah.
and come up with a system that I think seems to work really well. And you can't say that about jQuery. Like
Okay.
jQuery does not mean no bugs. Like that's just not the thing. So
If you look at the commit history of Google Clojure, it's actually growing over time. So like within Google, there are more and more people committing to it. Like there'll be like 8 commits per day to that thing.
uh-huh. Uh-huh.
It's like it's pretty amazing. So
Yeah.
so yeah, we depend on this thing that's largely used by one company, but the other like I guess Scala.js and some of these other things also use it. So it's not just ClojureScript that's using
Oh,
Clojure. You know,
interesting. I didn't know Scala.js used it. That's cool.
yeah, I think that's true. Um, so yeah, so it's not like ClojureScript's the only thing outside of Google that uses it.
Mm, mm.
But outside of that, do people use it? No, they probably use Webpack. Yeah. So it'd be interesting to if ClojureScript could support all these modern things that are out there,
Yeah,
especially the things that if one of these things lasts, and is around for a while and is going to stay around, it'd be kind of nice if it supported it.
right.
And the real problem is just labor to get it to there, or like the question is
Yeah.
who's going to do it.
Right. I often
Who's
look
going to?
at those things
Yeah.
like, man, I remember when people were switching to Webpack away from Babel, and there
Okay.
was probably something else in between, and it was like, this is how can your companies afford to switch so often and like figure out a new configuration that will work, and you spend
Yeah.
2 weeks setting it up, and
So I'm not
glad it hasn't changed in 8 years,
I'm not a JavaScript developer, but and the first time I ran into it was when I started messing around with ClojureScript and doing mobile apps that way, and I was surprised that I could write something using like React Native, and then go away and come back 4 months later, and it would no longer work because something in the bottom changed.
Right.
Because I came from a Java background where that doesn't really
Mm,
happen,
right, right.
except for the thing we said about Java 9, but
Java
but
9.
but but it's like, yeah, it's like I don't know, it's like this tolerance or this mentality to accommodate breaking changes all the time or every half year or so. Yeah.
Right. Well, I think the idea is like, well, this framework could go away any minute now. Let's
Yeah.
just ride the trend as long as we can.
Okay. Yeah.
We're gonna like break our own thing because you're breaking backwards compatibility because something else would break us. People are willing to switch right away anyway. Might as well switch to just the new version of the thing. I don't know.
Yeah.
I just find it very, very crazy, very stressful that there's so much going on that could break.
Yeah. Well, one example is Renatal and React Native and ClojureScript. We fundamentally can't use the latest stuff because it broke it, and no one's been able to figure out how to make it work with it. It's like it just takes time. The community is so small. Where like
Yeah,
if something breaks, you better hope someone in that community can figure it out, and no
right.
one has yet. It's like
Yeah.
why did they break it? Because we want to use the latest stuff and we can't.
I also find it funny, and we should probably get off of this topic.
Yeah. Yeah.
But I find it funny, like there's all these new React features and stuff. People are
Okay.
getting all excited about it, and it's like I haven't used a new React feature since like 2014 when React first came out,
Yeah.
and uh, I just think that people want a better language, and they're asking their framework to do that for them, to do what a better
Oh,
language
okay.
would do.
Interesting.
Like,
Yeah.
they're asking for, like, immutable
Mm.
data structures, and so they get Redux, right? And they're like, "Okay,
Okay.
well, we're gonna do it with Redux." They want, um,
Okay.
they want
S
go ahead, go ahead.
Well, the latest thing that smells like that is this talk about React hooks. There's
Right.
like and people started getting excited about I never even read about what this thing was, but then it seemed like a lot of ClojureScript people are coming around to being like, "Well, what's the big deal? It doesn't really do
Right.
much for it," you know? It's like we already have what we need. Maybe it's
Exactly.
giving people who don't have, you know, a Lisp kind of language, it gives them something to hook in. I don't know what it does, to be honest, so I shouldn't be commenting
It's
on it really,
kinda
but
like combinators for that's what it looks like to me. It's like
okay,
you have all these things, like, instead of using, like, regular JavaScript variables and, um, setting state on the object, you're doing, like, you're calling a function which will set the state for I don't understand it, but
okay,
supposedly these composable things that, um, you just it's very functional, you just run them and then the right thing happens,
okay,
and it's a way to, like, you know, get rid of the boilerplate of setting stuff up,
okay.
um, which we don't
Hmm,
have. We don't have the boilerplate that they have, so,
right.
like, we don't feel that pain.
Yeah, I can see that.
Um,
Yeah.
yeah. And again, think that that's like we have a better language. We don't
You don't
need.
need the framework to do it. Yeah, it's interesting. Yeah.
Um, all right, let's move on.
Okay.
So the other question from Jeff was about npm modules in ClojureScript
Right.
and what
Yeah.
the state of that is now.
Yeah. So I think it was like 3 years ago or so where ClojureScript gained the ability to use npm modules through a feature that Google Clojure has down in there. And if you try to use that, it's basically fraught with peril or pain because any library on npm, well, what it ultimately does is it puts things through advanced ClojureScript or Google Clojure Advanced. And so if you pick a random library out there on npm, the chances that it can survive going through an advanced is pretty low, or it may depend on something that won't go through advanced, right?
Right.
Um, but nevertheless, Google Clojure has this capability to put that stuff through there. So that's what ClojureScript's writing on top of. So there's this feature that is built into ClojureScript that lets you use npm modules, but it's like a nice theoretical thing. When
Right.
pragmatically speaking, you try to use it, it's a world of pain if you try to ever use
Right.
it with any given library. So yeah, so what Thomas Heller did with Shadow CLJS roughly is to avoid the advanced, and he built in a lot of cool tooling to just make it work with it,
I mean,
and kind of the
JavaScript
normal way.
is a concatenative language, right? You just concat
Yeah,
JavaScript to the end and it just loads it, right?
yeah, yeah. So Shadow CLJS arguably just works, right? You if you want to use npm, you just use it and it works. And I want to say that the reason is because it more embraces the normal way of using stuff. Um,
Right.
in addition to just good tooling that Thomas has built into Shadow
Right.
CLJS. So that's kind of where we are. I mean, the alternative also is to use Webpack, right? You can. David wrote a post to where you could basically use Webpack kind of manually to basically take a library off of npm and turn it into what's called a foreign library that ClojureScript can then load.
Ah,
So it's kind of like at a very abstract level, it's almost like manually doing the stuff that Shadow CLJS can do for you directly.
right.
Because in the end, you're avoiding advanced. You're just kind of using the library directly. So those are the two main ways of using npm modules right now: is Shadow CLJS or using Webpack to basically convert an npm module into a normal foreign library that you can just
Mhm.
use.
Okay.
So that's the two main ways. And in both ways, you don't have advanced. It'd be nice if I was really
You have
excited
advanced
recently.
on your ClojureScript code, right?
Yeah, on your ClojureScript code.
But
Yeah,
not
yeah,
on the JavaScript stuff you
right.
download for
So
NPM.
so it makes me wonder. Like, so I guess you need to. I honestly don't know what you then do to try to minify all that stuff. I guess you can use Webpack or other things to try to
Right.
keep the size of that code base under control, if that's
Just
important to
gzip
you.
it.
Yeah, yeah,
Because that's what JavaScript libraries are all like. They're like 2 functions big.
yeah, yeah,
Not all of them, I'm exaggerating. A lot of them
yeah,
are designed for, choosability, right? Like, I need these 3 functions, and
yeah.
so, like, I know Lodash is like that. Like, each function from Lodash is pulled out into its own NPM library so
Mhm.
that you can just pick and choose what you want because basically people are doing manual tree shaking. Like,
Okay.
I need these functions and not the others, and,
Mhm.
um, that's what they do.
Yeah,
Uh,
so I think that, like, arguably the npm support that's directly in ClojureScript in theory could get better over time. Like Google Clojure is fixing bugs in there and making, like, they can
right,
potentially use, so it can get better, but it's like you're fighting against the entire ecosystem, not writing code that is Clojure compatible.
right.
So it's like, you have to question, like, the only way for that to really work is if everyone got on board and just started embracing Clojure's way of doing stuff, and
Yeah,
that's
that's
not going to happen, right? No. So, yeah.
right. So I do wanna point out in the show notes, which are
Mhm.
in the YouTube description, should be able to just click on that. I found some guides for how to do NPM modules and using a few different systems. So there's a line NPM plugin, there's Shadows CLJS, which is its own project system. Like it's not using line again, it's not using depths, it's its own thing. So it manages things in a different way. And then I saw one, did I include it in here? It was like how to manually do it,
Mhm.
um, which seemed very like a lot of lines, a lot of steps to get stuff working.
Mhm.
And I assume that this is what, yeah, that's the line NPM one.
Okay. Yeah.
Yeah, it's kind of a lot to do. Um, I mean,
Yeah.
I'm an old school JavaScripter. I used to concatenate my JavaScript together, and that was my build step.
Okay. Yeah.
Concatenate, minify, safe minify, just get all the spaces and stuff, and
Yeah.
then gzip it, and that was it.
Yeah. Or another approach is just not take on any dependencies. Just don't do it. Just
You can
unless it's
write
a
your own
really,
notepad. You heard it here, folks.
well, I mean, unless it's like something that really gives you something that you really need.
Right.
I Yeah.
I personally am of that opinion. But of course, I'm
Yeah.
sure that there's stuff that I don't even know about that if I knew about it, I'd probably be like, oh, I wish I could use this.
Yeah. Yeah.
But still, folks,
Yeah.
like I remember the days and I still appreciate it. It never broke.
Mhm.
You just throw all your JavaScripts into a directory,
Yeah.
run cat asterisk, pipe it to like output.js,
Yeah. Yeah.
and that was your JavaScript. That
Rock and
was
roll. Yeah.
the script tag,
Yeah.
Uh, you could still do that. That's still a
Yeah.
possibility.
Yeah, I mean, that's a breath of fresh air, just because every time I ever try to use anything in the JavaScript ecosystem, it's like it's not gonna work. It's painful. And like,
Right,
I
right.
just want it to work. And
Cat
and like,
cat
yeah,
has not had a regression in, like,
yeah,
30 years.
man. It just works.
Yes, just works.
Before Apple coined the term, cat was doing it.
Right. Apple's just works is different from Unix commands, just works.
Yeah. Ah,
All right. Well, thank you, Mike. I was unsure about that topic, but you did a good
well,
job on it.
yeah.
And of course, if you have questions, you can email us or put them in the comments, and that would be really awesome. Let's move on to the REPL. Let me see if I can bring it up.
Alrighty.
It's the REPL.
We've got the old school REPL this time. So I see it now.
Is it
Let's see if it
it's
shows up
showing
in
up in the
YouTube.
live stream? Yes.
There it goes. Yeah, with a 15-second delay.
Right behind the Google logo. That's cool.
Yeah.
All right. So y'all can see this. Right. So our exercise is in the show notes. We're going to make a multiplication table. And this is basically, we're going to have a function that takes 2 integers as arguments, and it's going to make a matrix and multiply them together. Multiply so that the I and J indices together.
Okay.
So I have to type, right, Mike?
You have to, yeah, because we're going that old school where we're not even
Yeah.
sharing.
Yeah. Cool. Right. So let's go. I'm going to call it matrix, and it's going to take an X and a Y. So that's like the number. Let's call it rows and columns.
So if you were an old school imperative programmer, your first reaction to this would be like a nested for loop, right?
Yep.
That would be my immediate gut reaction to this kind of problem.
Initialize a variable to an empty array, or, it might have to, I might give it some dimensions or something, like a 2-dimensional array. But in Clojure, I would do something like this.
Yes, that's what I do too, as a for.
I do I is range R.
And
then I do nested for comprehensions like this. And I just want to see what this is going to do.
Okay.
I'm going to do I times J.
Okay.
And then it's not going to be vectors, but I just want to see.
Okay.
Matrix 2 by 2. Let's see. Let's do 2 by 3 so that I know which one is the. Okay. So there are 3 columns. That's good. And the multiplication looks right. No? Now what? I just had to do, and this one might be too easy. I have to have a big discussion about it.
We can always discuss.
Discussion and like trying different variations.
Yeah.
What?
Okay.
Okay, let's try matrix. So 10 by 10 obviously is going to be nice.
Okay. So we should talk properly. One thing to tangent to talk about is what happens if you put both of your I and J in the same for.
Oh.
You go down this path that doesn't lead you to a good place, but it's a valid thing to talk about. Because you can doubly loop, like, put the J there and we can talk about what that means.
Yeah, so that's really a good topic.
Because it does like do the Cartesian product over both of those things in a sense. It does its for comprehension over both those things in a
So let's look at it.
That's what we're talking about, right? So in that case, you get one sequence out of it. That's one way to characterize that.
Right. It'll give you a flat sequence of all of the multiplications instead of rows and columns, which is nice to have sometimes. I sometimes look at people's code where they have like maps and like chains of maps, and then they call flatten or something on it. And I'm like, you really just want a single for. Like that would do everything you need.
Yeah.
I like for comprehensions. I probably use them more than I use map. I find map with an inline function to be less readable than a for.
Yeah. And I think for has gotten a bad rap because its macro generates a lot of code, and a lot of people tend to look at it in a pejorative way. But we're all doing this language because it's easy to write succinct code in, right? If you were too worried about that kind of stuff, you might not be programming in this language in the first place. So I would say just do it the simplest way you can at first, right? If the for makes it look cleaner and it's optimal enough for what you're doing, then
I find that it makes it look really clean,
Yeah.
especially that you can do like filter in here. So you
Yeah,
can
you can
do
do all types of cool stuff. Yeah.
in so you could do like not equals ij, so you can skip the ones where they're
The
equal,
diagonal one. Yeah.
right? The diagonals. Which isn't what we want, obviously, but you can do it, and you can do a let in there in case you need a variable. You can do, ij. Use that occasionally.
Mhm.
I like that it gives you a flat list. I find that that's like one of the best features of it. Um, yeah, it does compile to some weird like recursive function calls, which could be difficult, but that's what macros
Well,
are.
yeah, it's like
They're
you
not
can express
weird.
a lot in this little mini language here, right? And it can expand out into what it needs to implement that.
Exactly.
So
I know people who really like doing maps and stuff. It would be cool if there was a for that was transducers, right?
oh yeah.
But
Mm,
that's that's kind of weird. I don't know how to do that.
yeah.
All right, to
Okay, so
build
your original correct solution involved 2 fours. Yeah.
2 fors so that we could have a nested lists, and then
Mhm,
I'm converting them to vex.
mhm.
Is that the best way to do it? I don't know. I don't know if if it really needs to be better than that, faster than that. What do you think?
Let's see. So that I think vec is fine. Like instead of like
In
into vec,
Yeah,
that's just more verbose for the same thing.
right. What would it look like as a map? As a nested maps. So let's see. So we could do a map
Okay.
V, right?
Okay.
And then
Yeah.
it's gonna
Mhm.
take an I, and then each I is going to be a map V with a
Uh-huh.
J,
Okay.
and then we're gonna return times IJ. And so this would be range C, because that's what corresponds to the J.
Okay.
And then this closes that function. So it's going to be range R.
That smells right.
All right.
Yeah.
Okay.
Mhm.
So this might be faster. I don't know. But
It looks harder to read though for me.
to me, yes, this is
And
definitely.
even if you indented it better, it would still be
Yeah.
it's like
There's no
it's
good
harder.
way to indent these like nested functions
Mm.
that makes it that much better. It's going to move to indent because I'm not in an editor. If I indented this here,
Mhm.
and then I indented this,
Yeah, just to
leave that, and then this range would go over there. Hmm.
yeah, I think I can read that a little bit more easily than the
Yeah.
single long line, but so if you do it this way, then you can maybe start to consider transducer versions of all this stuff, right? Because
Yep.
and you could start slapping. You could make the functions themselves. You could use into basically. I don't know if I'm being clear, but you could basically,
Right. I mean, the interesting thing about this,
yeah,
we know
it
it's
would get to be really messy.
finite, right?
Mm,
We know that R and C are numbers, and that like we're not going to have a stream that never ends or some unknown amount.
yeah.
Um,
Mhm.
so you kind of want to just generate the whole thing. Um,
Wait, what is the source of map V anyway? Doesn't it look like transducers inside of it? Can't remember. At
oops,
least for the singularity one.
I don't have source.
Oh, okay. You should be able to require it then, right? But that's weird that it's not there. It would be Clojure REPL.
Well, for all.
Oh man, I've forgotten about all since I do ClojureScript so often.
Right here it is.
Yeah. Okay. So
Okay. It is an into, so it doesn't do anything special. It just does an into vector. So the only
So it's
thing
fast, right? Or at least the single, like the one that takes a single collection, uses a reduce, and it's using a transient and that thing
oh,
near the top.
yeah. But it's still oh, it is using a reduce. Okay, so it's not doing a regular map. Um, interesting.
And
'Cause that means it's not creating a sequence.
my intuition is bad on some of these things on which ones are faster. Just
Yeah,
have to
they
try them.
test it, yeah. And plus, like, unless this is in an inner loop, it probably doesn't matter. Okay, so there was a complication that I put in the show notes where we can pass in any, uh, binary operation, not just multiplication.
Oh, okay.
So, I mean, that's obviously like a two-line change. So we could put in an F here. So now we can do like
Hmm.
it's a multiplication table, but we can do an addition table. Or,
Yeah, this is the kind of thing that still, even to this day, I'm impressed you can do in a Lisp. And it's the kind of thing where if I mention this to my kids, they
uh,
take it for granted. Like, yeah, you can, of course you can do that. Like, no, you don't normally get to pass in a function like that.
right. Let's do minus tables. There you go. Another function.
Hmm.
Max table.
Oh, that's cool. Is that going to work? Yes.
Yeah.
Yeah, sure.
So, hmm, sure, why not?
It can be. Yeah.
I wonder what that looks like. I want to p-print that. Like, I know that the people watching, y'all are awesome, by the way. Thanks for watching. Oops. Clojure, oh, not Clojure Core. Clojure that p-print. Um, I know that y'all can see what's going on and how fast I'm iterating on this thing. Like, I just don't know. Like, imagine you're in another language. It just would take forever to try this stuff out.
Oh, yeah. I mean, I've been doing some development recently where I have to drop down to the layer of doing stuff in Objective C,
Uh-huh.
and I'm like, oh, I got to write this function in Objective C, and then you're like, I don't have a REPL. I have to
Right.
like run my whole app. Yeah.
Yes. You have to create
You,
like a little test runner or something. And I've been working on a course called REPL-driven development in Clojure, and what's striking me is how simple it is. Like, it's like basically, um, after you type some code, compile it and, maybe test it, and then do that again and again and again. And, um, I think that as someone who's been programming in Lisp for so long, like, I just take it so for granted that you can just do that. And, um, so I've had to, like, dig deep and, like, really figure out, like,
yeah.
what is it about REPL-driven development that I miss when I'm in other languages? And it's just this, that I just came up with this function. I did a couple versions of it. I tested it out. I could look at the source code of the function I was calling. I I pretty printed it, and, like, I've I haven't had to, like, go to Google and, like, say, "How do you do this in this language?" And I'm
Hmm.
I've everything has been very small steps. I've been able to, like, get into flow. Like, I can control the size of the steps. If I was really unsure about how to implement it, I could do smaller steps and compile each one and test them. And if I'm very sure, I can do bigger steps and test them. Whereas in a language like Objective-C or Java, like, you're basically the size of the chunk is really big, and if you're not sure, because you're like, I'm not an iOS developer, but
Right.
I can get by with Objective-C, but, like, I would be really unsure about a lot of API calls, and so how long does it take me to learn whether what I did was wrong? And
Yeah. Yeah.
in Clojure, it's like seconds. In
So
Objective-C, running it on a simulated iPhone
oh, right. Yeah.
while loop, it could be like a minute. It could be 10 minutes.
Well, when I was a kid learning how to program, when I was like, whatever, 15 or whatever, messing around on basic computers, that experience was pretty close to this, or it was the closest I'd ever come to this, where you just flip on the computer and there's a basic prompt there.
Right.
And if you're an impatient kid, you can just start messing around and try things. Now, it wasn't as good as like a functional language like this Lisp is, but it had a lot of the same characteristics where you had a prompt at the bottom of your screen.
Right.
You
And you
could
had a
type
run
something
button or
and
something, and you just
yeah. Or
run.
like kids in school messing with Apple IIs, and you try something, like,
Yeah.
and you immediately get feedback, syntax error or whatever, right there on the line, and you try doing different things and you interact with the computer, right? And it makes me wonder, like, if it's difficult for brand new developers to even get into things these days when you have to like have so much scaffolding around stuff. Maybe it's okay if you're doing something like Python or whatever, and you just start up a little, because Python has like a little REPL, right? You can.
Yeah, so that's a good point. We actually have a comment about that in the
Okay.
YouTube comments, in the chat, I mean.
Mhm.
Yes, a lot of languages do have a REPL.
Yes.
But and you can do a lot of this stuff, right? You can do a lot of what we just did, which is we're at a REPL, we're typing, and we can make a program right there. But and everything should be theoretically possible that we just did, like that we do in Clojure. It's theoretically possible, but it's not refined, I guess, over time the way a Lisp is. Like the Lisps like are made to do this. And so a lot of the stuff that you have in like JavaScript, Python, Ruby, it's possible, but it's more hoops to jump through. You have to like make a little loader, or you have to do some step in addition. I work in an editor that is connected to a REPL, so it's different from a playground. Playground is cool. I like that feeling of like, okay, let's make something little in this playground, but then I want it to be in my code. And how do I load my? It's not just like a one-way trip. One-way trip is easy. It's got to be a two-way trip. I've got code in an existing project, and I want to use it in my playground, and then have the results of my playground, some of them wind up in my production code again. And back and forth. Like, okay, now I want a new playground. I want to start over, but load this code, and I'm going to do another little session getting something else working. It's that whole process, that whole cycle, that smooth, like working alongside a REPL where some stuff stays in your file, some stuff is very temporary, stays in the REPL. I just have not found that anywhere else.
Right. And another thing you get with
Go ahead.
with this is the data literals, where you can more easily create a vector or a map, or copy and paste them and just toss them around, right? Like they were actual things that you're messing around with and interacting
for sure.
with.
And Enzo Cavallo, he brings up a good point, that like you can actually start your web server from the REPL, right? So like if you're you load up your web project, your web application, and you start modifying code, and you're like, okay, I'm ready to run it. There's just like a start function somewhere that you've written, and it starts everything up. And then now you can, you go to your browser and test it out. And then you need to change something. You just change it, recompile it, reload your browser, and it's there.
Yeah.
It's just a different experience. You usually can't do that in a playground. I've never seen a playground that has like the full capability of the language.
Another thing that I only started to get recently, and I saw Stuart Holloway mention it in a talk. I think it was where the idea is that you may be working on a large program,
Mhm.
and my mentality is usually like, oh, I need to get this entire program running, and I can REPL into it, and then I can start to mess around. But
Mhm.
then there's this alternative where, like, yeah, maybe it's a big program, and you have coworkers who know how to really get the whole thing running, but you're just working on like a little piece in the corner of the
Right.
program, and you can at least get it like it's like barely working, and like it's throwing some errors, but at least the part that you're going to work on is there, and you can get into that part of it and REPL around and mess around with the peer functions you're working on in there.
Right.
That notion is kind of cool, and that's kind of like, if you come from like a C background or a C++ background, you get very used to the notion that you have to get past the compilation and the linking step, and it
Mm.
all needs to like work, and then you bring the app, yeah.
Right. And
But
you
then
have
you
that
go,
you have that same issue, I feel, with, Haskell. And now it might be
okay,
better. It's been a
okay,
while since I've
you've been
programmed
in
in
it, yeah,
Haskell, so, like,
yeah,
oh my goodness, like, I
yeah.
might be putting my foot in my mouth, bringing up static
But
type.
it reminds you of that, yeah.
Yeah, where it's like, okay, your program, needs to have, consistent types,
Mhm.
and I know that when I'm programming, like, halfway through, like, converting types, I wanna try something, right?
Yeah,
I
yeah,
don't have a working I can't run it because I wanna try, "Wait, is this gonna work?" Okay, let me step
okay,
back.
yeah,
So
yeah,
so people talk about, how types help them refactor, and it's totally true. If you wanna make you have a working program,
mhm,
you wanna make a change somewhere, like change a type signature or something. You
yeah,
change the type signature, and then you just follow the error messages, and the error messages tell you, "Hey, you
yeah,
called this here, it needs
yeah.
2, but you passed it 3. Oh, okay, that's what I'm changing,"
It
and you
might
just
be
go and
the
change
exact
it.
shape, but you can listen to some music while you're doing it, and you just
Yeah,
get there.
exactly, and you just
It's
jam.
mechanical, yeah.
Right. My problem with that, it's true, it's a true statement. My
Yes,
problem with it as an explanation for a benefit of static typing is that rarely is it the case that I get the refactoring correct the first time. So I might say, "Okay, let me
okay,
try this with a third argument,"
okay.
and
And then
then
you followed
halfway
all the way then
through,
through.
I realize,
Ah,
"No,
yeah,
that's not really what I wanted to do."
okay, yeah,
So the problem is I've been just going through and fixing what the
the
compiler has been
mechanical
saying
thing.
before I
Ah,
even
yeah,
realized that, that's not gonna do what I want,
okay,
right? And so with if you didn't have those checks, so you had a dynamic language, you would realize that earlier. And so you would say, "Let me just work on this small
okay,
part of
yeah,
the code,
yeah,
and I'm going to change the type signature in this small part and see what that feels like."
yeah,
And then say, "Ah, no, I don't really want that third argument," or "I need a fourth. I didn't think of that. I need a fourth."
okay,
And so, um, this is what I'm sure there's some process you can do in Haskell,
mhm,
like, you start by just copying all your code and rename them, like, function 2 and, foo2, bar2, and so
yeah.
you're then just working in a smaller thing, but it's just a lot more work.
No, you're right. Like I was working on a Java project uh, back in, like 2004 or so, and I had just come off a C++ project. And one of the coworkers on my team like broke the build or something. He committed something that wouldn't even fundamentally compile. And my reaction to that was like, oh crap, how am I going to get any work done now? And then I didn't realize, like, oh, in a Java project, you can actually kind of muddle through and load up the other part of your program with one part of it being broken. Um, but that's kind of rare to work in that mode. Usually the whole thing compiles properly. But I guess with like Clojure, you can even be more in that mode if you want to. Like, lots of stuff can be broken all over the place, and you can still work on your little part.
Well, there's a different notion of broken.
Yeah,
There's
yeah, yeah.
the
So maybe
notion
the
of
generalizing what you're saying is like, if you don't have a type system, you can more easily you can work with broken programs more easily. Like, lots of stuff can be broken all over the place, and you can focus on the little bit that you want to do and refactor in your own little part without worrying too much about everything outside of you.
That's
You don't
right.
have to do the
Yep.
yak shave and follow all the,
Right.
compiler
The
errors. Yeah.
disadvantage is that you don't get help once you do figure out what you want. Uh,
Yes.
you
It's
know,
always a trade-off. Yeah. Yeah.
it's nice to have. It really is. Um, it's just a different way. Um, I wish that we could bridge those gaps, right? Bridge the two divides between static and dynamic. And I
Yeah.
really think like doing this REPL-driven development course, I really think that the divide happened really early. The divide is the same divide as between batch and interactive programming.
Okay. Yeah.
So it's just like
Yes.
a
Yeah.
little, do you remember this? You're
No,
not.
but I've read about it like in the 50s
Yeah, right.
with
Um,
punch cards. Yeah.
uh, right. So the idea was
Okay.
that most places thought like if what you would do is you would make your program and you'd put it in a queue.
Yes.
Some people would then eventually get to yours and
Yeah.
load it up,
And you
and then
don't dare
nothing
touch the
else.
machine. You give it to
Yeah,
someone else. Yeah.
exactly, and then you would
Yeah.
come back in like 2 weeks or a week, and you would look at your printout, and you'd have an error, and you'd be like, "Ah," and
Mhm.
so, the bulk of the work of the compiler and stuff is to try to protect you from that.
Okay.
Say, let's do more checks. Let's
Okay.
more pre-processing, more analysis, so you don't have to wait those 2 weeks to find out that you had a bug. And whereas the interactive is, in order to share this computer, let's let people like terminal in, and we'll
Yes.
do fast switching between all the terminals and all the programs that they're running. And you should be able to submit like one line of code, have it run, and then instantly see the answer. And so this was what like the Lisp people were doing. This is like
Yeah.
a John McCarthy was really pushing this big time. And so the idea was we don't need the checks because you can look at each line of code and see if there's a bug in it because you're running one at a time. And I think that we're still running that same divide, like you hear it in the rhetoric. People are like, "Oh, but it protects you from errors." It's like, but I don't need to be protected.
Okay.
Show me the error right away, and there's no problem.
Yeah. No, that is like okay. So it is like this parallel if you think about that era and Blicklighter and McCarthy and the very first people who were arguing for being able to have a terminal basically and being able to interact with this very expensive machine.
Right.
It's like,
Right. Exactly.
yeah, that's kind of what we are doing in the REPL. We're able to interact with it
Right.
and communicate with your program and find out what's wrong with it more quickly.
Exactly. Now,
Yeah, yeah.
I do think though that they've got, on the batch side, they've got a lot of cool stuff that we don't have, and we've got cool
Mhm.
stuff that they don't have.
And you want to bridge it somehow. Yeah,
Yeah, we need to have some like let's shake hands after 50 years of being diverged.
yeah.
I think that'd be really cool. Just because
The
like
dream.
so what happened was we both lost or we
Mhm.
both won, right?
Yeah,
Like
yeah,
everyone has their own machine now.
yeah,
Right?
yeah.
So you don't need to share. So
Right.
that happened. And then, all the batch stuff got faster. So compilers got faster. So you can basically like look at the Go
Mhm.
compiler. It's so fast. You
Yeah,
can you don't have to wait the 2 weeks anymore. And
right.
so that kind of pain has gone away on that side, but they still have all the nice analysis. And we've been oh on the interactive side. I guess what I would want to say is that they've been borrowing more from us than we have from them, and we need to start learning from them
Oh, okay. Yeah.
more.
Well, at least I feel like I'm happy that I've been on the other side of the fence in the past in my career, so I know what it was like there at least.
Yeah.
I'm glad I'm experiencing this side of the fence now,
Yeah, yeah.
Yeah.
Ah,
And yeah, it's like hopefully there doesn't need to be a fence. You can just bridge it.
sure.
Yeah, you can just have both.
Exactly. Oh, well. Okay.
Yeah.
folks, this has been a good show. We're a little bit over. Thank you for tuning in. Don't forget, if you want to be notified of the new episodes, we're on Twitter. So find us at Apropos Cast _cast. Follow us there. We announced the show minutes before, so plenty of and
Yeah.
also if you subscribe to the channel, there's like once you subscribe, there's like a bell icon that you can click on, and that one will let you know when we're going live, so you can catch us then. Yes, and we always appreciate comments and questions and suggestions. So find us wherever fine closurists are found, Twitter, Slack, email. Any last words, Mike?
No, those were some good questions. I think that if we have more of that kind of stuff, that's good. It gives us meaty topics to chew on. Right? So yeah, if you guys have questions, send them to us. Yeah.
Awesome. See you later.
All right.